Hello, hello. Welcome back. So, tonight, hopefully, will be the last night working on the Lambda stuff. I think I have enough to finally fix it once and for all. This is after hours of debugging and learning. And I think we're close. So just to recap, the last time what happened last time? We got to a point, okay, we figured out we actually got past the Mussel library when we were trying to build Swift and make it run on AWS Lambda. And we actually got past it because we put the built library into the lib64 folder, and I don't know why. That just made it work. We couldn't put it into the same app folder. We had to put it into lib64. I'm sure there's a setting somewhere, probably the environment variable, but I'm pretty sure I printed it out and nothing was there. But I'm fine with that. Now, the last issue that I think is the last thing is it couldn't find lib standard C++ and libm, which is the standard library for C applications, I believe. Well, actually, it had it. It was just using the wrong versions of it, which I think to solve that, we just have to build it on Amazon Linux Docker. Previously, we were building it off of the Swift, which was built off of Ubuntu, which I think had the wrong version of it. So if we built it on the correct version, then I think it should work. Which is actually kind of interesting because that just makes me realize how fragile these programs are if you build it off of the wrong version. Like, these are shared libraries, so if you update the shared library, wouldn't a lot of applications break? I don't know, and I don't intend to find out tonight. I just want it to work. All right, so let's get back at it. I would just be so happy if our Lambda started to work. That's all I really want. Then we can actually get to the core of our application. The interesting stuff, not this build server stuff. I became a DevOps engineer in the past 4 streams. I was expecting to solve this in like 1 or 2 streams. This is going on way longer than I thought, but let's try to finish this. Let's finish this so we can actually move on to the interesting stuff. All right, so the things I changed since last time were, now we are the build image is Swift Amazon Linux 2. By building it off of Amazon Linux 2, that should have the proper versions of stuff, and we are installing all of these to help with the build. And we were hitting into one last issue, which was here. Cannot find JE-malloc. Malloc. I don't really know how to say that. But the way we solve that is we have this. So all we have to do is, let's move this up. And what we're gonna do is, just like how here we're taking that, we want to put that into the build server as well. And since this isn't going to change much, I'm going to put it early on in the process. Where are we going to put it? I don't know. We can either put it into staging, or or we can put it into lib64. Or user local lib. What if we did that? I don't know. Let's try it out. Okay, so the way we run this is you have to say docker compose build. We are using docker compose to make it easy so we don't have to type in too many things. And let's see, I don't know if this is gonna work or not. And it's gonna take like, I remember, last time it took like 5 minutes every single time we made a build. So there's that. Also, this line is not doing anything because apparently that's not in the Yum repositories. I'm just gonna comment that out. I'm not gonna comment it out. We're already caching this. Actually, I'm gonna comment out. If it fails, it means this step didn't work. I should put this step after this step because I don't want to run this. You know what? This is not the slow step. The slow step is the building part. The rest of it is relatively quickly. Like, see, Yum ran like 35 seconds. That I don't mind. I don't know. Actually, this is also taking 30 seconds. The Swift package resolve. So maybe I should put it. We'll figure it out later. I just want to figure it out first. So close. Hope your evening's going well. Or day, whatever time you're watching this, I suppose. Whoa. I don't think it would take much longer now. We just have to figure out this one library. So once we figure out the build, hopefully that'll take less than an hour. Once we figure out the build, then we have to figure out how to put it onto AWS Lambda and put it into the Terraform script. So once it's in the Terraform script, it's basically automated. And this is kind of interesting because the Terraform script, all it should do is bring up AWS Lambda. We might need a separate step to publish new versions. And I'm not 100% sure on how to do that yet. But if we can get just like one version up, like, I don't know, making a build takes a while. But if we can get one version up just by saying like Terraform apply and having the current version up, oh, that'd be nice. I don't know. I don't have that part solidified in my mind yet. We'll figure it out. Not too worried. I think it's doable. Wow, Swift package resolve does take a while. I do not want to do that again. 180 seconds, that's like 5 minutes. 4:30. No, that's 2.5 minutes. That's a lot of time. 300 seconds is 5 minutes. That's 60 times 5. 300. I feel like the streams aren't that interesting if all we're doing is just waiting for builds. Ooh, what is this? 22 hours. What does this mean? File saved. 3 minutes ago, probably. That's interesting. I guess VS Code has history. That's cool. Never knew that. And an outline. I've been interested in looking at NeoVim. I want to have that set up. Also, dot files. I feel like I've been talking about that for a while, but I feel like I should have one. I've been developing for like over 15 years. Since 2009, professionally. That's 15 years, wow. And I can't believe I don't have dot files yet. It's just every single time I install stuff manually, and sometimes I don't even install it. And I thought I had a thing here. Maybe I don't. Is it in this one? No, this is old. These are old. I've updated already. Interesting. Well, maybe we'll see it after this. That's 5 minutes. What a wonderful stream. What a quality content right here. Maybe that's an interesting idea for a screensaver. Does anyone ever still use screensavers? I feel like I haven't really seen that in a while. Oh, it's actually building. I still don't really understand why we're using... Where is it? Here. Xlinker. We're passing this flag to all of the linking steps. What does NB stand for? New Brunswick. Note well. Interesting. Nota bene. Haven't seen that before. I would usually do like note. Is incompatible. And I think this was here when we generated Vapor. So that's interesting. I don't even know why we're using this. Why can't we use the default? Why do we have to use this? Is there a default? General purpose malloc that emphasizes fragmentation avoidance and scalable concurrency support. I guess the default doesn't have fragmentation avoidance or scalable concurrency support. What does JE stand for? It stands for Jason Evans. Wow. That's impressive. You get your name inside of the application. That's impressive. I can just make something called JS malloc. Oh, there we go. Okay. Okay. let's see this. Shall we? Docker. Let's go into this machine and take a poke around. Okay, so this is in user bin. So there's something called LD Gold. This is all the applications inside of this. Here you go. Cat. And I guess that's just the binary. Okay. I wonder if we can try to execute it. Nope. Okay. Oh yeah, this is the new terminal stuff that I was talking about. Okay, so I don't want to run through all that again. So what I'm gonna do is copy this, put it right here. We did that. There we go. Used all the cached versions of that stuff. Oh no. Stop. Let's put that back in. What? Why is it? Why is it running this again? I was hoping it would skip that. Because this one actually takes a while too. Oh man, okay. Well, if you're gonna just run that, I'm just gonna change everything. I don't want that, I don't want that. Let's just run this again. Build, we'll do that. And then, so what we're gonna do is put it into the build folder. So hopefully it has access to it. If not, we'll figure it out. And while we're doing this, let's learn, shall we? This is an interesting way to see things, and that makes a lot of sense. Like, I've always thought of static variables as global variables, and that's because they are. But one key thing about these are that they are only visible inside of a single function, or I guess in a class. They're scoped, which, I mean, it's kind of obvious. But that is interesting. So like, I mean, that's the same thing as how classes kind of scope together functions. Static global variables also count as global, even though they can only be accessed by the functions in the particular file. And this might be most applicable to C programs. Other languages like Swift, I guess, is what we're doing. I guess you can access them elsewhere. It's just scoped to, like, you have to say class dot shared or whatever, you name it. Static function is also interesting, because I guess typically when you call a function, it's an instance function or instance method, because it belongs to a class. And that means you need an instance of whatever type, whatever class that you're calling it from. But if you make the function static, then it's like a global function, or a function that doesn't need an instance. So you can refer to that function by name. That doesn't really make too much sense from this specific line, but I guess that's fine. I don't know if this actually helps. We mentioned earlier that the declaration of a function or variable is a promise to the C compiler that somewhere else in the program is a definition for that function or variable, and that the linker's job is to make good on that promise. Okay. So it's like saying here, there's a global variable somewhere, external, which is here, but also maybe the function, maybe also the function too. Why global in it? You can see all the dots can join up. The linker can fill in all of the blanks. The linker is typically invoked with LD. I mean, I guess Swift is doing that behind the scenes, the Swift compiler. As for object files, I'm lost. We can use nm to examine the resulting executable file. So I don't really know what an object file is yet. Maybe that's the .o. Duplicate symbols. In C++, the situation is straightforward. The language has a constraint known as one definition rule. It has to be exactly one definition, no more nor less. The relevant section also mentions C has to be exactly one definition of any function or initialized global variables, but the definition of an uninitialized one can be treated as a tentative definition. C allows for, at least does not forbid, different source files have tentative definitions for the same object. Okay. It's interesting. So library files has a .a extension. The command is called AR. They're also normally prefixed with lib and passed to the linker with a -l option. Kind of like this, -l. Followed by the name of the library, malloc, without prefix or extension. So -l-fred will pick up libfred.a. So we're looking for a -l, we're looking for a libgemalloc.a, I guess, according to this. It's crazy how I have to learn C. How that builds to learn Swift. Files objects.ho.ho. Normally libc. Having static library has an obvious disadvantage. Every executable program has a copy of the same code. This can take up unnecessary disk space. If every single executable file has a copy of printf and fopen and such like. A slightly less obvious disadvantage is that once a program has been statically linked, the code in it is fixed forever. If someone finds and fixes a bug in printf, then every program has to be linked again in order to pick up the fixed code. To get around these problems, shared libraries were introduced, normally indicated by a .so shared library or shared object, or .dll on Windows machines and .dylib on Mac. That's where the dynamic libraries come from, I suppose. I mean, I used to use Windows a long time ago, and DLLs were everywhere, and Mac, I'm vaguely familiar with how frameworks build .dylibs and static libraries somehow. .so I see every once in a while, but I guess that's more of a Unix thing. For these kind of libraries, the normal command line linker doesn't necessarily join up all of the dots. Instead, the regular linker takes in a kind of IOU note and defers the payment of that note until the moment when the program is actually run. So that's like dynamic linking, I suppose. If the linker finds the definition for the particular symbol in a shared library, then it doesn't include the definition for that symbol in the final executable. Instead, the linker records the name of the symbol and which library it is supposed to come from in the executable file instead. When the program is run, the operating system arranges these remaining bits of linking are done just in time for the program to run, before the main function is run. A smaller version of the linker, often called ld.so, so that's where ld comes from. Linker daemon, maybe? That is not a daemon. Often called ld.so, goes through the promissory notes and does the last stage of the link, and then and there, pulling in the code of the library and joining up all the dots. This means that none of the executable files have a copy of the code for printf. If a new fixed version of printf is available, it can be slipped in just by changing libc.so. It'll get picked up next time any program runs. So maybe the way to solve the shared version problem is similar to semantic versioning, where you say like, oh, I need a version, like there needs to be a minimum version 2.35. It can take higher, but lower is not good. So then you'd have to update your operating system or update your shared libraries. Maybe that would be interesting. There's another big difference with how shared libraries work compared to static libraries, and that they show up in the granularity of the link. If a particular symbol is pulled in from a particular shared library, let's say printf in libc.so, then the whole of that shared library is mapped into the address space of the program. I think I missed something here. How shared libraries work compared to static. Okay, so shared is the dynamic stuff. Static is built into the executable. If a particular symbol is pulled in from the particular shared library, so dynamic library, then the whole of the shared library is mapped into the address space of the program. This is very different from a static library where only the particular objects that held undefined symbols got pulled in. I don't understand this line. Where only the particular objects got pulled in. Does static libraries, is that .a? So is it built? Is it done? Okay. Same thing. Okay, so shared library itself is produced as a result of with references between objects. Are already pulled in. LDD, that's what I was using on Unix platforms. It shows the section that it depends on, together with an indication of where those libraries are likely to be found. For the program to run successfully, the loader needs to find all these libraries together with all their dependencies in turn. Typically, the loader looks for libraries in this held in the LD library path. So maybe I can do something like this. Nothing. Okay, so and I think I feel like I'm getting closer. I just need to put this stuff somewhere where the build linker can find it. Add archive file to LD will search its path list. With path list. Okay. So there's also something called OTool. Ooh. I could try to put something like that, but I kind of want to find out where it is by default. So it invokes the C compiler and the C++ compiler. And the Swift compiler. And the linker. Wow. That's interesting. What? I guess that's the current directory. Yeah. That makes sense. Man, I am really doing some compiler debugging right now. Oh, jeez. Okay, so code generation. Swift frontend are symbolic links to the compiler binary, and invoking SwiftC causes the executable to detect that is compiler driven. Some ChatGPT help here. When I use the Swift compiler, default path where system libraries are located, user lib and user local lib. Custom library path, so I can pass in this path embedded within the executable shared library itself using the rpath. So I have those as options. Actually, I know this is not there because we printed everything. in, no? Dang, ChatGPT is talking back at me. Not bad, ChatGPT. Except you're wrong. This is the Docker file for okay. They already have a Swift version. I'm not trying to change the Docker file. Okay, this one looks better. So this and this, and then maybe we can also try this. System library path. So let's do that. And I'm gonna do it twice just cause. If I pass in to the linker, how should I do this? I'm not trying to change the Docker. I don't know much about Yum. Look up package. Time to learn about Yum. Where to find? This does Yum update, but it doesn't do make cache fast. So install and link against it. So we're kind of doing this here where we've downloaded 5.3.0 and we ran sudo make install or just make install. So actually, what if I think I already did this, but let's try it out. Let's try it out. Why is it running this? It's supposed to cache this one. Something's not right. Force resolved versions. It doesn't look like this updated. As long as the package.swift and package.resolve do not change, they should not have changed. So I don't know why. I don't know why that's running again. Well, that's unfortunate. So once you sudo make install, it will install it there, and then that hopefully should work. We'll see. I mean, I'm copying everything into the same folder. We'll see. And I'm copying it to 3 different places, just in case. I was also thinking maybe we can like, ooh. But I'm not really using, am I using this? I think I'm using something else. Like we could add this somehow. Be right back while this compiles. Still compiling. Man, this takes a really long time. 400 seconds, that's like 6 minutes, 7 minutes? It's 500 seconds. Dang, it's like 6 minutes, 7 minutes every time. That's not good. So that's from scratch. Oh. Hey, we went past something. So that's interesting. I think this is the one that worked really. Hey, gotta wait. Wow, we did something. That's cool. Okay, so why is this breaking now? This is fascinating. Because this is the one that worked before. This used to work. Until we swifted to Amazon Linux. So what that means is we probably want this one. Probably. Gonna try to run this and see what happens. Why is it compiling again? That's frustrating. Come on. There's zero reason for this to recompile that step. How long did that take last time? Here. Took 113 seconds. That's not too bad. That's 2 minutes. I can wait 2 minutes. Swift package one surprisingly takes a long time, so as long as that one is cached, 2 minutes is okay. One other thing I'm kind of been toying around with the idea is getting a new Mac for development purposes. Macs are expensive, and I guess technically I don't need a Mac. Well, I kind of need a Mac because I am doing a lot of iOS development right now. iOS and Mac development. And I do have a desktop that I can actually do stuff with. It has a lot of memory. I can play games with it. Maybe I should do that. But I don't like Windows. So I need like a Linux machine. That sounds appealing. I could dual boot. There's an idea. I don't know, Macs are just so expensive. Could get a 4090. Oh, almost done. There we go. Ooh. It might not work. That's not the library I was expecting to fail. Wow, but the great thing is everything else... okay, except for that one. So there's two things not found. The good thing is it found lib standard C. That's really good. And lib M. It doesn't... Is lib M even here? Okay, so we got lib C. Here's lib M. It found lib M. That's great. We're almost there. Oh my god, we're almost there. There's two more things. Let's fix the Musil one first. I want to fix the other one first, actually. For this one, wait, I know how to fix this. We did this last time. Hey, look at that. Glad that knowledge came in handy. All right, but the last one, lib crypto. Wait, what's this? Why is there two different? Why are there two different versions? We're almost there. We just need to figure out. This should be on this machine. Unless it's on one of these machines. Which that doesn't make too much sense. Let's do this. Let's do this. It's either libcrypt or we didn't get it. Lib crypto. So all we have to do I'm gonna copy lib64. There we go. I felt like I could do the same with the other two. Yeah, look at that. All right, looks like the linker found all of them. So in theory, this should work, right? Ooh. What happened? I think it was this one. Load our backend at 1. Exited. So what's in the logs? Hello? Dang, this takes up a lot of RAM. Maybe this wasn't the right one. Oh, right, I need to build it. Exited. I need to clear out these. There's too many of them. This doesn't seem... Oh, maybe it is. Okay, time for the next battle. So we got all the linking stuff working in theory, but now our application can't run. I kind of want to see it running on Docker first before I try to move it to AWS. Because if it's not working here, well, first of all, it would be nice to be able to debug locally. I don't want to clear all of these. Okay. How do we go into the container? It's not running. So run it. Run an interactive shell for a non-running container first. Find the image. sh docker container run. It's not running. Ooh. I don't want to sign up. Wow, it's still up. That's good. Okay, cool. Okay, so we got the Docker up just by making it sleep. It's a weird way to do things, but okay. Docker run. Where do we do execute IT? And we just do the shell. There we go. And now I'm in. It's interesting how... Oh, we're in the app section. So there's Bootstrap. Segfault. What does that mean? Nice. Glad that works. Okay, so we're gonna try to debug this segfault. And what it's saying is what ChatGPT is saying is we could run it via LLDB. Hopefully there's debugging symbols. There probably isn't because I copied it out, so I'd have to go to the build machine. What? Wow. Invalid address, fault address. Moosel. So it is. It's Moosel thing. Okay, that's kind of interesting. Never really used LLDB like this before. So what if we just What if we just put it all in here? Let's try that out, shall we? I don't know what this is for, but let's just do it. Of course, that's not gonna work. Okay, so Mosul is still giving us an issue. From here, Mosul. I don't know why it's even relying on it. In the build server, we didn't even need it. Also, this is probably not needed. So but I built it and I copied it into lib64. So if I remove this symlink, I'm not sure if that will still work. Of course it won't work. Because it's not found. I want to kind of test it on the build server. So what if we did that? So I'm going to debug the binary that it built, probably run LDD on it on the build server, and also check what libraries are available there. Because in theory, it's still Amazon Linux.
Whoa. That's okay. 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 That's good. This is great. This is great. It's weird. Why would you build something but not know where it is? Also, where is... Where is Mosul? That's weird. That doesn't make any sense. Unless it comes from here. Like as a transitive dependency, that's the only thing that kind of makes sense. It's all right there. Oh. There we go. I think we made some sort of realization that this needs that. So actually, can't I do ldd libmalloc.so? Check that out. Okay, that's a good realization. So it's not, that's, well, that makes a lot of sense. Swift doesn't rely on it. Gemmalloc does. Okay, my thinking right now is maybe this is it. And why is... Why do I even need this? I shouldn't need Musel at all. Why do we need jmalloc? Because that's not available here. Okay, so this is probably gonna rerun, even though this already reruns. But what I want to do now is, instead of this step, maybe I can do this. Let's try this. So what we're trying is, we're gonna build jmalloc directly on the build server, because I think if we run it on Alpine, it uses Musel, which is not good. Okay, at least it's using the cache version of Swift package. I do not want to change that. So I'm gonna avoid that by doing that. How does this work? tar xef. Oh. Right, of course, of course. Why is it piping? There we go. That was weird. Okay, so we put it into that file and then you tar. Just like here, you curl it into this file and then you tar and then into the file. Then you tar and then you cd into it. Then configure, make, install. What do you mean? It doesn't look like a tar archive? About tar xj? What does J stand for? Huh. Okay, so it's one of those. did that. XVF. That's the same. What do you mean it doesn't look like a tar archive? Okay, I want to turn that off. That's annoying. Oh, that's so much better. Oh my goodness, that's so much better. Also, hey, it's just what I wanted. Didn't want to see any items on my desktop. There's not really anything there, but I like the clean look. Gzip, bzip 2. So in here we download it and we tar it. Here's an idea. Okay, this is what I wanted to do. Tar xvf. Not XVV, it's TVV. So what did it work before? Oh. Well, that kind of explains it. The file is 0. That's why it's not BC2. But why is it 0? Still not downloading anything. So what did I download locally? I downloaded something. Oh. Interesting. So we have to say -L to make it follow redirects. And okay, well, there you go. -L to make it follow redirects, and that fixes it. So let's undo all of this. And you have to say -L. Oh well, sure. We'll stop the Docker container and then we'll run it again. Although I need to comment this out. And this will run the build again, but that's okay. Well, that's the point anyways. Cool. Oh, wait, is it downloading? Oh, it's making, okay. So it looks like it actually got to the make install portion of it. Wow, it's already 2 hours. Sorry, getting late. Oh. Okay. No problem. I think it's going. Okay, so while that's going, I'm just gonna do a little bit of shopping. I want a 4090. Oh, looks like it made. Gaming laptops are interesting. So my budget, I think $2,000 is a good price point. Although, if you think about it, just the GPU itself is already almost 2,000. So if I wanted that, it might need to be a little bit more. Where's the desktops though? I want a Linux machine, but then again, I do have another gaming computer that I could just like add another
like add another hard drive or dual boot, then I can have either Windows or Linux, but I don't really want to mess with that hard drive particularly. So I'm not sure what I'm going to do. It's been a while since I've had Linux as my main operating system. That could save me a lot of money if I don't use Mac. Mac is pretty nice. But I feel like in my developer state right now, Linux seems really appealing. Dang, $3,000. $4,000. I like the color. Ooh, and it has 64 gigs of RAM. This one does too. What's the difference? This one's a little bit more powerful CPU. They look pretty similar. This one has a slightly newer CPU for $500. Oh, but that also has open box. This does look pretty nice. Oh. That's the whole reason why I did this. I thought this was the main folder I was looking at, but maybe it's not. What? I thought running make install would fix it all. So it must be user lib. Where does it install it? Here's install. Here's installed lib. Package config. I can't read this. Okay. We're almost there. We're so close. So we've built gemalloc on this machine. And it can't find it in the linker. Which we can verify here. And the reason is because I think it needs to be here, which is weird because it built it in here. Let's just move it. Okay, so to move it, you just have to say run. It's probably a copy thing, right? But I think copy copies it from outside to inside. So I just want to say run. Copy, and it's gonna be basically this into what if we did this? Let's try that. Well, we didn't do that before. So I'm not going to do that. I'm going to do this. Yeah, let's try that. Man, I don't want to spend $4,000. I could buy a Mac with kind of similar specs, a little bit weaker. I think all I need is 32 gigs of RAM. 64 is pretty nice though. I had that on my current desktop. Not gonna lie, pretty nice. I should probably just use my current desktop. Still pretty powerful. And then I could play games right here. I just need to move some stuff around, and I could potentially use that for streaming too. That's an idea. The tricky part is if I want to do Mac development. I could try to use like Mac on the cloud or something, or like remote desktop into a Mac. Please work, please work. I want to be done with this. Finally be done. I'll say I'll go until 11. 20 more minutes. 15 more minutes. And if this doesn't work, we might go into a 50, part 5. Which I really don't want. Been learning so much about compilation and linking. I don't remember anything about Swift development anymore, iOS development anymore, or Mac OS development. Oh. That's interesting. So on this computer, on this one, it looks for it in /user/lib. And that seems to work. We'll just up that. How? Why? So it built fine, but it's building from user lib, but it's running from /lib64. That's wild. There. Now it's connected. If I can just find it. Oh, it's up here. Okay. Here it goes. You think it's gonna work? Breathe a sigh of relief. I think this is saying stuff about AWS, but that's fine. That's totally fine. It's all environment variable stuff. But the most important thing is it works. It ran. We did it. We did it. I'm just taking a second to relax because, oh my goodness, that was stressful. Okay, here's what we're gonna do. Let's put all this stuff back. We don't actually need any of this right now. Nothing, none of that. So we're copying from build. We actually don't need this or this. This one's interesting. We can leave that. All right. I think that's pretty clean. I mean, I still need to remove all the comments and stuff, but let's try it out. Wow, that was fast. Oh my God, it works. It works. Okay. This is great. This is great. Oh my goodness, we can actually get back to Lambda. I mean, Swift after this, or back, actually, even back to Lambda. Okay, so we're gonna copy from that container. App, I think. Everything in the app folder into our own app folder. Wow, that's a lot. See how big that is. It's probably going to be over 50 megs. I might try a S3 upload. That's the only way I can think about doing it right now. Guess we'll create a new bucket. I don't know what to call it. My Pomodoro bucket number. Yeah. Sure. I'm kind of creating it with the defaults. I think it's okay. I think it's still private, but that doesn't really matter to me right now. Because I literally just want to use this for, oh cool, for uploading this. That's all I want. so close. We're so close. Oh man. Never thought I'd get to this moment. Really? Why me? Why me? I wonder, do I need all these? Do I need this? Do I need this? Probably do. Alright, how does layers work? Time to learn. So copy. I think this is what it's saying. We'll find out. I don't even know. But what that means is I don't need that. So now when we go into our dashboard, now when we go into our applications, now when we go into our Lambda functions, here in layers, you can add a layer. What's this? It's cool, but I want custom. There's no point in me doing layers right now. If the size of it's just gonna be the same, there's no point. I might as well just zip it all in the same thing. Not sure if this is gonna work. So I just deleted the underscore pic, which was about 30 megabytes. I don't know what that is or does. It's probably important, but I'm just gonna see. Just gonna see what it does. And this node is super frustrating. This is the only problematic library now. What do you mean it's incompatible? Okay, I think we're getting somewhere. missed something. Well, I think that's a good place to stop for tonight. Okay. I think we got really far, which is really good. So what happened? We learned that you don't need Mussel. I think the only reason why we needed Mussel was because I built Gemalloc on a system that relied on it. So like during that linking process, it built with that in mind, but then when I moved it over, that environment didn't have Mussel. So the solution is simple, just build it in the same environment, which is good. And that means now we don't rely on Mussel, we still rely on Gemalloc, which is frustrating, but that's fine. Apparently there's a bug with Swift that requires us to not use the static version of Gemalloc. But that's okay. We were able to figure it out, and we were able to copy the version that we built into the location that we know where the linker is looking during the build process. And we know where it looks for when it runs. So we copied it into that location. Well, we copied an app, but that's okay. It still looks there, so that's fine. We don't need anything else. Everything else I can just clean up here. We don't need that. Man, that's gonna be a lot of cleanup. What is this? Lib? I forgot to consider that. We can probably comment that out. This is for debugging. This was for debugging. I think ChatGPT changed a few things, but we do need it to say this now, which is fine. We don't really need that. We do want Amazon Linux. for debugging. This we don't need at all. We don't need these. I don't really want to move this right now. Ideally it'll be up here, but just gonna leave that for now because it takes a while. But I do want to build. Ooh, that was fast. So that is interesting. It's because we don't have OpenSSL. But can I copy it into app? I can. And I wonder if that's the issue, actually. It's 2 megabytes. I wonder if there's a way to make the Swift smaller. Because it looks like it runs. Okay, so that's so close. Build a container, huh? Is that my next route? Is that really... That's really my next route, isn't it? I don't want to use EFS. Well, I think we know what we're gonna do next time. Really didn't want to do that route, but that's fine. We're learning, and it's painful, but hey, that's you know, that's how we become better developers, right? Okay, I'm gonna call it there. It's getting late. Thanks for joining me. We're gonna play around with ECR next time. It's gonna be fun. All right, see you next time. Good night.